Okay, lesson 27. We're now going to use this is 6.3 from the textbook. Using systems to model data. Systems being systems of equations. We'll be doing systems of linear equations, meaning one or more equations. Yeah, so we're going to do a couple of things here. It's best to just go straight to an example. So a lot of basically applications here, things we've done. Some of the techniques are things we've done before, but we're applying it to sort of new scenarios. And my first example is going to be two competing cab companies, or two taxi companies. Are competing in a large city. We're going to call them Gary's and Harry's. Gary's taxi charges, and so if you've ever ridden a cab, they immediately charge you a minimum fixed fee. That's sometimes called the pickup fee. We're going to call it that. $5 pickup fee. And these are not realistic. I don't think they ever charge you $5, although, I don't know, maybe in certain parts of the city they do. I'm going to keep nice round numbers that we can kind of get our heads around. So whether realistic or not, Gary's Taxi charges a $5 pickup fee plus, and then you get in the cab and you start riding along and they start charging you per mile. So the mileage starts ticking up as you go, or your cost rather, the fees start ticking up as you go. Okay, so it charges you a $5 pickup fee plus $1.75 per mile. That I think might be reasonable. I don't know. I haven't ridden in a cab in a long time. Harry's is the other one. And so when we get to describing them with functions, which we will, we're going to call Gary's G and Harry's H. So I've chosen some letters that we can distinguish pretty easily. Harry's Taxi, or Harry's Cab Company, charges a $2 pickup fee plus, so initially it seems like you would go in that cab because it's cheaper. Well, not necessarily, because they charge you $2.50 per mile. So one of them has a smaller pickup fee, but they charge more per mile. The other one has a larger pickup fee, but they charge less per mile. And that means it's a little complicated to figure out which one is going to be cheaper. And we're going to do that. We're going to start analyzing this. We're going to use function notation and functions and linear functions specifically. We'll let x be the number of miles traveled. Yikes, this is going long, but and g of x and h of x will be our two functions, are the costs of, traveling x miles with Gary's for g of x and Harry's for h of x respectively, meaning Gary's is g, Harry's is h. Okay, I did not anticipate taking up the whole board with the problem, but there we go. We're going to do a couple of things with this, but first, let's just state the equation of g of x and h of x. Well, I'm going to do one first. Find the equation for g of x. And we'll spend a little time on this one, and then once we get a feel for how this works, h of x should be a little bit quicker. Hold on 1 second. Okay, now to analyze how this is going to work, it doesn't give you a whole number of miles. It could be decimals. You could be traveling 2.7 miles or 3.2 2 miles or something like that. But to analyze it, I'm going to stick with some nice whole numbers, but be aware it doesn't need to be a whole number of miles. And what I'm going to do is, I'm going to build a table. That's not part of my answer, and I won't be able to plug into G because I don't know G. I'm trying to find the equation of G. But instead I'm going to use this description and think about what happens if you travel 1 mile, 2 miles, 3 miles, then that should be enough. I could do more, but the idea is for G of x, instead of me plugging into a function that I don't know, I'm going to analyze this whole thing about it charging $5 per mile and $1.75 per mile, and using my understanding of this fee scheme, this payment scheme, I'll figure out what the G of x is for what a G of 1 is, the cost of traveling 1 mile with Gary's, the cost of traveling 2 miles with Gary's, and the cost of traveling 3 miles with Gary's. And then I can kind of tell what I would do with these x's to get the final cost. So here, even though normally I would fill this in with the actual value, the function value, instead I'm going to write out an expression that would be used to find the cost of Gary's. Okay, so 1 mile. I'm going to travel 1 mile with Gary's. Ready? I get in the cab right away, and immediately he charges me $5. So I'm going to pay $5 right away, or I'm going to be charged $5 right away. That's not my final cost, because I'm going to add more to it because I'm going to travel 1 mile, and he's going to charge me $1.75 for that 1 mile. So I'm going to be paying $6.75, and I'm not even going to bother writing that because I don't care about the actual cost. I want to be looking at what's going on with the 5, the 175, and the x's here. Okay, so I could easily compute it, but I don't care. 2 miles. So I'm going to now ride 2 miles with Gary's, and I'm going to pay $5 right away. And then I'm going to pay $1.75 for the first mile and $1.75 for the second mile. So I'm going to pay that twice, 2 times that. And I'm not going to, again, I want everything I'm saying I'm going to write down mathematically, but I'm not going to do any computations. I don't want to condense it. I want to see all those pieces. Lastly, and if I need more, if I'm still not clear on what's happening with this, I could do more, but I think 3 should be enough. So let's do 3. I'm going to travel 3 miles now with Gary's. On a new night, on a fresh night, so I'm calling him, I get in the cab, he charges me $5 again, and then he's going to charge me $1.75 per mile, and I'm going 3 miles, so he's going to charge me 3 times $1.75, whatever that is. I don't know what that is off the top of my head, and more importantly, I don't care, because I want to see that, and let me highlight some things. You can see where this 2 goes here, 2 times $1.75, because that's the rate he's charging me per mile. The 3 goes here, because I'm being charged $1.75 per mile for 3 miles. And then I didn't have the 1 here, but I could throw it in. I didn't bother with it, but yeah, to be consistent, let me treat this as 1.75 times the 1 mile I'm traveling. And now you can see the pattern, and now I feel it's enough for us to construct this function. That's going to be a linear function, and it doesn't matter which order you put it in, but the way I wrote it based on us paying the pickup fee, the fixed cost or the flat fee first, and then being charged per mile. And I'll stick with that. I'm always going to be charged $5, and then I'm going to be charged an additional $1.75 times the number of miles. And here, since it's a function with an unknown x, and x is your number of miles, remember that's what x represents. That means we're going to multiply the 1.75 by the number of miles x. So that's the rule for the function, and you can now look at it and see if we wanted to use this to find the cost of traveling 1 mile, we plug in g of 1, which is that. G of 2 for 2 miles, we plug in 2 there for that. G of 3 miles we plug in there. And now this is good for any number of miles because we could use it for 9 miles, 13 miles, even decimals it'll work. If you travel 8.4 miles, you can actually plug in 8.4 for the number of miles and you get an accurate cost. Okay, so that's it. You can rewrite it. Well, no, sorry, that's not it. Let me analyze it, because I got some terms associated with it. I could switch the order it doesn't matter what order I put it in, but if I do, that x is always multiplied by that 175. And these have terms associated with it that are not really from, well, they're from more like business sort of thing. The $5, because it's just a fixed amount that does not vary, you don't pay different amounts for the pickup fee. This is sometimes called the fixed cost. Or it's like a flat fee that you pay, and then you pay additional for the number of minutes used on your phone, or the number of miles you're traveling, or the number of pounds your package weighs. But there's always this, like, you know, monthly fees that they make you pay that's just a flat rate. Anyway, the $1.75 is called your variable cost. I don't test you on these terms, I'm just making sure you've seen them before, because when people start analyzing this kind of thing, they do refer to those costs, or those terms, and in business applications a lot of times they will use those extensively. Okay, make sure you got that down, because I'm going to erase it. I definitely need that space now. Okay, I'm going to let you do this one on your own for a little bit. It's just going to be find the equation for h of x. Equation for h of x, yeah. You do not need to do a table. The table can be very helpful for sorting things out and clarifying what happens with the costs, but you do not need to. For something like this, if you understand how it works, the fixed and variable costs and where they're going to go, which one's getting multiplied by x, there should be an x in there, and it should be these are all going to be linear. Then just put it together. You can just put your answer, and that's fine. I will mention that the next lesson, lesson 28, is going to have a more complicated pricing scheme, and in which case we'll come back to this table because it can be useful when it gets more complicated especially. So don't hesitate to make a table, but don't feel you need to. Okay, so pause the video, put it together, build a table if you want. I'm not going to. Well, yeah, I'm not going to. Okay, so same idea. You're going to pay your fixed cost, which is just a pickup fee. How much do they charge for the pickup fee? What am I looking at? Harry's. Harry's taxi charges a $2 pickup fee. So you're going to pay just a flat fee of $2 right away. And then plus $2.50 per mile. So you're going to take that $2.50, and that's a per mile basis. That's your variable cost. So whatever number of miles you're traveling, you got to do that number of miles times $2.50 plus the $2 that you had to pay for the pickup fee, the fixed fee. And that's it. Oh, sorry, this is my answer here. With some notation. Okay. Now, the question would be, in real life, an application of this would be, if you got to travel 3 miles, who should you call? I do want you to get used to function notation here. We've written them as functions, and as we go along, I want you to stick with function notation. So, how much does each cab company charge for a 3-mile trip? So don't mind just piecing together the amount. I want you to actually get used to, we want to do both. We want to do G and we want to do H. And think about what notation we would use to basically figure this out for 3 miles. Okay, and what you're doing is G of 3. So 3 is the number of miles. You're plugging that into G, and to do that, the notation is G of 3. You put the 3 inside there. And that means X is getting replaced by 3. It doesn't matter if I use that form or that form. I know I'm not being consistent. And we compute it. And this time I do want an actual answer. And after that, you're doing Harry's. $10.25? Okay, and this is money, so dollars, so that's the nearest penny. You just leave it as is, no need to round. But usually if you have money amounts and you have to round, you round it to second decimal place, which is your penny, down to your cent. So a lot of these rounding things will say round to the nearest cent, because you can't be paying out half a cent. Okay, we're not done with this problem. I want also the cost of Harry's for a 3-mile trip. Go ahead and do that. That means you're doing, and write function notation, get used to it. H of 3 we're doing. The rule for H is over here. And on my calculator I'm just doing the whole thing. 2 plus 2.50 times 3. And the calculator will follow order operations properly. 9.5. You couldn't in theory write $9.5, and that's technically correct. It's $9.50, but usually that would be written as 9.50, so that you think of it more as $9.50, which is the same thing. $9.50. Okay, but anyway, if the question, I'm not going to write it, but if the question was which cab company should you call if you're traveling for 3 miles? I mean, if you're a sensible person, you're going to call Harry's because they charge you a little bit less. Okay. Now here's where we're getting into systems, because now we're going to treat this as a system of two equations, g of x and h of x, which actually, I'm going to write it in the corner over here. G of x was 5 plus 1.75 times x, or you could switch the order of that. H of x is equal to 2 plus 250 times x. And those are my two cab companies and their functions for the costs. D. For what number of miles is the cost the same for both companies? Okay, so it's a system, but we're going to handle it a little bit different from the usual just solving a system, because we're treating Gary's and Harry's as a set of two equations. Now, we just have to, we're going to work with function notations to start off with, and I just want to interpret what I'm trying to do here by noting that the cost of Gary's is given by g of x, and the cost of Harry's is given by h of x. And what I want is I want them to be, I want a symbol here. Now sometimes later on it's going to be, you want Gary's to be more expensive or Harry's to be cheaper. Other times you want Gary's to be cheaper, so you can put an inequality there to capture that idea. We are going to get to that in literally 10 minutes, but for now, let's just get used to the idea that we want them to be the same. And so we want g of x and h of x to be equal. Okay, so I want you to start off there with function notation, just so you don't start getting confused by the numbers and craziness and thinking about x ahead of time before you even just figure out what you're trying to do. And what we're trying to do is find out when Gary's is equal to Harry's cost. So this is basically interpreting this problem. And it's good to work with that first. Again, just getting the symbol correct in the correct direction if it's an inequality or whatever you're going to do. So we're going to start with that. Now we're ready to start working it, and now I'm ready to actually refer to these equations. I want Gary's, which is 5 plus 1.75 times the number of miles, to equal the cost of Harry's for that same number of miles, so the same x. And I want to find the x, the number of miles that makes these two equal. And that's what this first sentence or this first expression or first equation represented. But now we're going to replace them with the actual rules that we can now use to solve it. So now we're solving it. Let me put the notes. Cost equal. Alright, and I'm going to do this quickly because it's just your usual solving. I'm going to get my x's together on one side. What was that? 0.75x. to divide by 0.75. Four? 4, exactly. It could be a decimal, but again, my examples tend to be, let's just work with nice round numbers, and you can deal with the decimals when you have more time to spare when you're working on the homework. Okay, labels or units. What are these? For what? Whatever x is. And x is a number of miles. So 4 miles is when the two, if you're traveling 4 miles, you could pick either one because they have the exact same cost. What does that cost? Well, we did not figure it out. But that's your next question. How did I write this? Okay, since we know it's 4, the next question is, how much does each company charge for a 4-mile trip? Okay, we did this literally 5 minutes ago with finding the cost of each company for a 3-mile trip. We're doing the same thing but for 4 miles. G of 4, 5 plus 175, plugging in 4 and for x. I got 12. I do like you to make sure you know the units. You're supposed to write them, and I'm supposed to mark you wrong if you don't. I honestly, I don't want to be super picky, but I do want you to be conscious of units, especially for a problem like this where you got miles and dollars, and it is important you know which one is which and what you just solved for. Did we solve for 12 miles? Nope. It was the 4 that was inputting was 4 miles, and the output of the function is cost in dollars. That's $12. You can even write, this is not part of your answer, but if you want to just give extra detail, I'm going to put it so that for your notes you have extra detail. We just figured out the cost is $12 for 4 miles for Gary's. But it wants each company. So we're supposed to do H of 4. However, if you understand the work that we did with D and what we just did with D, you should know the answer to this. So think about it, don't start doing this. Think about how D pertains to this, because that's kind of the issue here that I want to cover. I'm still going to do it anyway. I'm going to verify it, but the idea is we found out that the cost of Gary's and the cost of Harry's is the same when you travel 4 miles, so when x is 4 miles. And here it's looking at x is equal to 4 miles. So they're supposed to be the same cost for 4 miles. So in theory, if we've done everything correctly, and we have, I assure you, this should be 12. And if we're confident in our work and we understand everything, I could save that time and not have to bother doing it. And I'm going to do it anyway. Let's just verify, but keep in mind we're supposed to be getting 12. If we don't, somewhere along the line I got messed up, but nah, I'm good. 12. Okay. And that's just to illustrate what we found. So 4 miles, both companies charged $12. But for 3 miles, they did not charge the same amount. One was cheaper than the other. Where am I at now? Okay, so I don't want to have to keep doing this over and over to figure out which one is cheaper every time I take a cab ride with one of these two companies. So let's see where I'm going to do this. I'm going to write my question here. For what number of miles will Harry's be cheaper than Gary's? Okay. I'm going to erase there and do the work over there because it's going to take a few steps. But before I start plugging in these formulas, these equations for the functions, I want to start like I did here, where I just focus on just using g of x to represent the cost of Gary's, and using h of x to represent the cost of Harry's. And since they're comparing the two and talking about a particular relationship between the two of Harry's being cheaper, that means I can set up either equation or an inequality. And if I want Harry's to be cheaper, that means they're not going to be equal. So this is going to be an inequality. So either that or that. Okay, so think about it. The key thing being Harry's being cheaper. Does that mean Harry's is going to be a bigger cost or a smaller cost? Harry's cheaper means Harry's is going to be a smaller cost than Gary's. So if you know your inequalities, the mouth is eating the bigger thing and the bigger cost is Gary's. We're looking for when this occurs, but this is where we're going to start with. We're going to find and solve for the x's that make g of x greater than h of x, because that'll make Gary's more expensive than Harry's, or Harry's cheaper than Gary's. Either way you think of it is, that's the correct form. You could have started the other way, by the way, if you had put, I put g and h in alphabetical order, but if you could have put it on this side, but just make sure you understand that's not the same symbol. It's not the same symbol. It's a completely different reversal situation. I need the mouth to be eating the bigger quantity, and therefore I will need the mouth to be eating Gary's. So either one of these is a valid starting point, but just make sure you understand that that's equivalent to that. Okay, I'm going to do the work here. I'm going to do this one though. It doesn't matter. You both be the same. Okay, so I'm going to go up here and start working that. Now the thing is, I'm going to replace Gary's with its equation, replace Harry's with its equation, and then start working it and solving an inequality. And what it's going to be is it's going to be almost identical to this, except that instead of an equal sign along the way, you're going to have an inequality symbol. And you do need to keep track of it, you need to work the whole way through, because if you divide by a negative, it switches, and you need to be conscious of those rules for solving inequalities. So a lot of the steps will be the same as far as what I do, but I'll need to keep track of whether the inequality is preserved or whether it switches, and at the end get an inequality. And then we'll talk about how to interpret that. Anyway, Gary's 5 plus 1.75x, 2 plus 2.50x, and the inequality between them now. But as far as solving it, when we learned how to solve this, I often referred to equations and talked about you just would do the same steps if it were an equation. We're going to do the same steps as if it were an equation. Okay, so I'm going to be subtracting 1.75x. I'm going to do the exact same steps I did last time. But keeping track. Does it preserve or does it switch? I subtracted an expression. That always preserves it. I'm subtracting 2 from both sides. That's going to preserve it again. And here the dividing step is when you may have to switch depending on which way you went. Some people who work this out, they'll end up with negatives on that side and a negative there and have to divide by a negative and then switch the direction. The way I did it, I ended up with a positive coefficient, and when I divide by a positive, it preserves it still. And that's the end of solving the inequality. We're not done because we need to interpret it in terms of this. But let me mention, you don't have to write this down. In case you worked it out on your own, or anytime you work out an inequality in a different way from me, we talked about it when we did solving inequalities, but at the end, if I'd worked it out differently, I may have ended up with instead negative 0.75x on the left. You don't have to write this down. I just making sure you know that you may have moved things the different way than I did and end up with a negative 0.75x on this side, and that means you would have a negative 3 on this side. And if that's what you did, it's completely fine. Oh, sorry, it would be this way. Sorry. If you did it that way, it'd be like that at this stage. And then you would divide by negative 0.75, negative 0.75. and then you get x, you would get 4, but then because they divided by a negative, they would have to switch the direction, and they will get that answer. Which is equivalent to our answer. You don't get a different answer, you just get a different form of an equivalent expression. These are all the x's that are under less than 4. 4 is a bigger number, and the x's that work here are 3.9, 3.8, 3.7. Anything below 4 works to solve this. So these represent all the x's that are less than 4. What does this represent? All the x's that make this true, and the things that make this true, because the mouse is eating the 4, that means 4 is the bigger number. The numbers here that would work is 3.9, 3.8, 3.7. Those are the valid x's that would satisfy this. And so this represents all the x's that are less than 4. That's the exact same that's the exact same thing I said for that one. They're equivalent. If I graph them on a number line, I'm not going to do super detailed. I'm just going to put some tick marks. I'm going to put 4 right there. What does this represent? I'm going to put a hollow circle at 4, and I'm shading the x's, which are, again, 4 is bigger, so this is shaded this way. I didn't need to do this. They didn't ask for a number line. I'm just doing it so we all understand. If these people had done a number line to better understand their result, they'd put a hollow circle at 4 because 4 is not included, and then they shade all the x's, which is that. They're the same set, so it's just different ways of writing the same set. All x's less than 4. Okay, I'm going to erase because we're not done. I've got to interpret this. And so my interpretation of this is, it's asking what number of miles. So, like I said, 3.9 miles would make this work. So for 3.9 miles, Harry's would be cheaper. 3.8 miles, Harry's would be cheaper. 3.7 miles, Harry's would be cheaper. Okay, so Harry, you don't have to write the whole sentence, but I'm going to for your notes. Harry's is cheaper for, and you don't have to make it grammatically correct, but I'm just going to say under 4 miles. 4 miles is not correct. 4 miles is when they're equal. I want either over something or under something, or before something or after something, or something to the effect telling me which side we're talking about. And under 4 miles is what this represents. Those are the miles for which Harry's is cheaper. Okay. I haven't even taken a break or paused yet, but I'm going to finish this out. I'm going to take a break. Okay. I forgot what number we're on, but anyway. What are we on? Hold on. A, B, C, D, E. I think I just F, G. I'm going to say we're on G, but I could be wrong. Use 2 points to graph each linear function. Now am I making you do this for this homework? Yeah, you're going to be graphing, and because these are linear functions, they're going to be lines. Because they're of the form mx plus b. They're just written in different order, but your slope is 2.50, and your y-intercept is 2. But it's harder, it's going to be hard, for instance, this slope is 1.75. It's hard to go up 1.75 and then over 1 on a graph. So we've done it before, and I'm going to emphasize, if it's not such nice things where you can just count rise per run and get precise points, you probably want to just use 2 points to graph linear functions, and that's what we're going to do. Use 2 points to graph each linear function. Now, I think up to now I've been giving you a table. Even if I don't, and I refer to you using 2 points, you have to know that you need to basically pick 2 x's, 2 input variables, and then plug in and get your corresponding output variables, your function values. So I'm going to do 2 values and then plug it. I'm going to pick 2 x's, and I'm going to plug it into G. And that'll allow me to just draw a line and grab G. I also have to do for each linear function, so I have to do it for H as well. I can use the same x's. I mean, I could make a whole new table, but I could also just cram H of x's over here. It's up to you. So I can use different x's, but now I'm going to keep it simple, and I'm just going to pick 2 x's, and then plug it into G, and plug them into H. And then this is going to be a very big graph, because I need it to be semi-accurate and show some details, but your input variable is x, your independent variable, or your input variable for function notation, And then this is either going to be g of x or h of x. You can just call it y generically if there's conflicting functions on top of it, or you don't have to label it at all if you don't want. But okay, so let me see how I'm going to scale this. I'm going to go to 8. And I'm making this nice, because I do want to see some detail and related to the things we just solved for. What's my money situation? I'm going to go by 5s, and I'm going to go up to 25. Okay, so I think I'm good with that. Okay. And the way I've scaled it, and I think you'll always be provided with an axis, so you can see visually what graph you're working with, and pick something from the far left and the far right. So I'm going to just use 0 and 8. And I'm not going to write out any computations on the board, but we should all know how we're doing this. For this, I'm plugging in 0 into g. And that's going to give me 5. And I'm going to plug in 8 into g. And that I don't know off the top of my head, so let me just do it. And I got 19. Okay, and I'm ready to graph g on here. So I can do h now and then graph the 2. I'll just pretend we're just doing g, focus on that. 0, 5, right there. 8, 19. Right there, and then I'm just drawing a line straight through. And that's my model for g of x. That's the cost of Gary's as you go 1, 2 miles, 3 miles. This is going to give you the cost. We're going to approximate because it's a hand-drawn graph, but that's the idea, visually showing you that you're paying more and more the further you travel. And if you go 8 miles, you're going to be paying $19. $19. Okay. Remember it said to graph each function, and that means each of x as well. So along here, I'm going to plug in. And then you're not plugging 5 and 19 into there, you're plugging in your miles, 0 and 8, your x's, and you're just going to jump there. So you can imagine just crossing this out temporarily, and you're filling this table. X is 0, x is 8, plug both into h. Get h of 0, which is 2, and h of 8, which I have to actually do. And I got 22. I'm going to graph those. I'll put them in red so you can see, so we can distinguish between them. So be careful though, it's not 5 and 2. Again, it's 0, 2. Right about there. And then 8, 22. About there. Okay, and I'm gonna kind of, like if this were super accurate, I could just get a ruler and it'd be, you know, pretty nice. But here I have to kind of, because it's hand drawn, I got to kind of bend it to make it do what I want. And what I want is I want it to cross each other right here. So I'm going to force it that way. It may look a little bendy, but again, it's just a hand drawn graph. But make sure it crosses here when you draw it in your notes. Why there? Think about why there. I was very specific about making sure that they cross at this point right there. And also try to make it so that this is what it should be. Think about what this should be. Okay, but that's where they cross. Okay, the reason I made them cross at 4 because I know the costs were the same at 4. I erased it from the board, but that's one of the things we did. Both cabs companies for 4 miles, they both cost $12. Okay, so that's what's intended. That's where they cross. And again, I had to force it that way just because it's a hand-drawn graph and it's a little bit tilted because I'm drawing it sideways. But if you drew it, you know, with a ruler and very carefully with careful measurements on graph paper, and you wouldn't have to worry about it. It would cross pretty much there at 4, and that intersection point would be at 12. But anyway, let me actually put that in your notes. So 4, 12 is a point that they have in common, the point of intersection, and that's 4 miles will cost $12 for both cab companies. That's what we solved for. We solved for the intersection of the 2 lines when we did that solving. Okay, and then when we did that inequality, remember what the question was? It was, I forgot what the question was. Harry's being cheaper. Let's graphically look where Harry's is cheaper. Harry's is a red. Over here, Harry's is above Gary's. So along here, you're getting charged more by Harry than Gary. So Harry's is more expensive here. That was not what we saw for. Over here, the red line is Harry's, and here it's below Gary's. This right here, Harry's is cheaper, all the way up to there. So from here up to that intersection, Harry's is cheaper. We can see it graphically on here, and it makes sense now, but before we did that, we did it purely algebraically, and we solved for it, and we found out for under 4 miles. 4 was the intersection point, and we solved for h of x being less than g of x, and we've got a solution of x less than 4, and that's what we solved for, the fact that Harry's is below there. So this is all just to illustrate graphically what's happening with these two cab companies and what they're charging you, and you want to ride in Harry's if you're going under 4 miles. You want to ride Gary's if you're going over 4 miles, and if you're going exactly 4 miles, it doesn't matter because they're going to charge you $12 either way. Okay, we got more examples to do, but that's the most extensive one that I wanted to go through all the details, and then we're going to go a little bit faster through the rest, except for the last one, which is a whole new thing. Okay. Okay, next example is going to be similar to the last one, except you're not going to construct the models yourself. You will do that several times for homeworks, the Gary's and Harry's, and making the functions based on the fixed costs and the variable costs. Here I'm just going to give you the equation so we can just do the inequality type stuff. Suppose the price of a Big Mac which we're going to call M of T, or I guess Mac, and the price of a Whopper from Burger King, which has 2 P's, I know that. We're going to call that WT, are given by the functions below. Where T is defined specifically with a reference year of 1980. And you don't really have it doesn't follow the cab company thing where you have a fixed cost and a variable cost. Instead, these models would be based on just gathering some data. Don't write this down, but you can gather some data about the cost of a Whopper over the years, and then you would do linear regression. So a lot of times your linear models from now on, we covered it in the last lecture, but they'll come up again. You'll have to get a data set and use linear regression to come up with a model. And for homework, if you did your homework for lesson 27, homework 27, before you jumped into this video, you did an M of T for the Big Mac based on 5 prices during different years using linear regression. And if you did it correctly, this is the same model from that. M of T is equal to 0.091 T plus 0.911. The Whopper, you didn't do one like that, but this is also based on regression, and we're skipping it. I don't want to spend more time doing things we already covered. We just want to work with these 2 functions. The Whopper is 0.065 T plus 1.865. Okay, and I asked you based on the model on the homework 27, no, homework 26, sorry. Homework 26 is the last one. By how much is the price of a Big Mac increasing per year? Be based on the slope, right there. And since you're doing to the nearest penny, I think I asked for, you'd round there, and so it was $0.09, which is 9 cents, so $0.09. And then this one didn't come up on the homework, but that means the Whopper is increasing by 6.5 cents, 6.5 cents, 7 cents if you round up per year. Which means it's similar to the Gary's and Harry's in the sense that the Big Mac is increasing faster in price than the Whopper, although the Whopper started at a higher price in 1980. So Whoppers were expensive in 1980, Big Macs were cheap, but eventually Big Macs are going to overtake it because it's increasing at a faster rate. So it's that very similar thing of different slopes, and the Big Mac will overtake the Whopper. We're not getting into it. I don't think I'm even going to do a graph here. I want to focus on just, hey, let's just work with abstract functions and just get used to interpreting it using function notation and be able to answer questions like, in what years? Plural, so it's implying, will the cost of a Whopper exceed, so I do use that term in the homework, and exceed means is more than, I'll write that in your notes, exceed $4.50. To exceed means to be more than something, to surpass it. Okay, another thing I want to underline in red is years. It's implying multiple years, and so at a certain point the cost will hit 450 and it's increasing, positive slope. So that means that year it hits 450 and every year after it's going to exceed it. So this is going to be an inequality, and based on our knowledge of rising prices, it'll be after a certain year it'll be more than 450. But let's pretend we're not analyzing it intuitively, although it's good to have that intuition. We're going to analyze it purely algebraically. Big Mac's not related to this question. They don't mention anything about Big Macs. We want to deal with Whoppers. I'm eventually going to use this equation, but I don't want to deal with it yet. I want a clean W of t, which is the cost of a Whopper in that particular t value, that particular year. And I want to express something where it exceeds or is more than 450. And that's an inequality. So I want the cost of a Whopper to be greater than 450. And so that's how we're interpreting this problem. That's a good starting point. Don't start trying to write the equation. I mean, you can, but when people do that and they're not really, it's new to them, they'll wonder, which way does it go? Well, it's easier if you think of it as just the cost of a Whopper is WT and not have all those crazy numbers in my field of vision's messing me up and playing tricks in my mind. Just a clean cost of a Whopper, 450. You want the cost to be greater than 450? Boom, that's your inequality. Now we're going to solve it. So now we'll replace W of t with its expression, with its equation, and then we'll solve for t. But again, it's hard to go, ooh, watch your zeros. It's hard to just throw this equation in and figure out what you're doing with the 450. It's more overwhelming if you try to jump right into this. It's still going to be this, and you can, but I mean, if you are having trouble with it, work with the W of t and the clean 450, and it'll be a little bit easier for you to set it up with the correct direction. All right. Like I said, I'm just flying through the solving because that's from homework 4 at this point. Did I copy it down correctly? Yeah. Preserves, you got to keep track of that. Again, watch your decimal, it's 0.065, not 0.65. I almost messed it up myself. Okay, got 40.5. That cancels and I get t, and I divided by a positive, so I'm preserving the inequality, same direction. Okay. Not the answer to the question. I mean, we're almost there, but we need to interpret this in terms of years. And the inequality is going to be interpreted, again, I said it's either under 4 miles or over 4 miles in the cab situation. Here it's going to be after the year blank or before the year blank. So my answer is going to be of the form before or after the year blank. So that's what I'm going for, choosing if it's a before or after situation and giving a year based on this 40.5 being rounded to a whole number, and then convert it to a year based on your reference year as usual. What year is represented by t? Well, we're going to round this to 41. want to find out what year 1941 is. Add 41 to that. That's 2021 we're talking about. The year 2021 is when it's going to hit roughly almost exactly 450. We have to round, so it's not going to be exactly, but so that's the year in question. Are we talking about before or after? I mentioned before intuitively, knowing that the cost of a Whopper is going to increase, it's going to be after a certain point. It's going to be, so we have a graph like that of the Whopper. You don't have to write this down. And at some point it's going to hit 450. And that's approximately at t is equal to 41, which represents the year 2021. And when is it going to exceed that? Well, if we keep going, it's all the years after that. That should make intuitive sense, that it's going to hit 450 and increase in price, and it will exceed 450 all the years, all into the future, past 2021. Now, I don't want your intuition, I mean, like I said, your intuition's good. But I do want you to be able to interpret an inequality. It's maybe not as obvious and doesn't have that intuitive interpretation. So let me clarify that. Sorry, I'm going to erase this though. It's fine, I'm going to put it back up. I'm going to make a number line, which is always handy to visualize things. And I'm going to, instead of putting 40.5, I'm going to use 41. Hold on, let me... for your notes purposes, I'm worried about how you're going to look at it later. Okay, so we're rounding that to a whole number of 41. We're now looking at the inequality t is greater than 41. I'm going to draw a very crude number line, where I put 41 there, and I just make sure I shade the correct direction. To the left of it is 40 and 39 and so on. To the right of it is 42 and 43 and so on. And let's look at this. 41 is there. Which way am I shading for this inequality? Don't worry about the interpretation of the Whoppers and the Big Macs, just shading an inequality. The t's are bigger than 41, so that means it's this way. And since these are t values, these are years. That's the year 2021, that's the year 2020, that's the year 2022, 2023, 2024, and so shaded that way means all the years after. I'm going to correct my answer here. You don't need to write that full sentence that I said. You can write after 2021, that's fine. I just wanted to make sure you know that you're giving a year, and you're also giving me a before or after, depending on the inequality. Okay. I'm going to leave this up because I need it. I'm going to use it for this part B. We just have one more part. Just another example of this. This one's not going to be as intuitively easy to figure out, but in what years, plural? Will the cost of a Big Mac, or sorry, I don't want to use the word exceed twice, but I could say that. Will a Big Mac cost more than a Whopper? I want to see if you can tackle that, so pause here. We are eventually going to use these equations, but if you start taking these equations and throwing them onto the board right away, onto your paper right away, it can be a little more confusing. Remember what I recommended? I recommended not worrying about that and using M of t and W t and making an expression or equation or inequality, just using those as condensed forms representing the cost of a Big Mac and the cost of a Whopper. Similar to this, but with not 450. W of t and M of t, and some sort of symbol between them representing the idea that the Big Mac costs more than a Whopper. I'm going to start. Doesn't matter which one I put first. I'll just put M first and W first, but it doesn't matter. What matters is you getting that right, and I want which one to be more? The Big Mac to be more. I want the Big Mac to be higher in cost than a Whopper. So that's the direction. That's our inequality. And now I'll replace them with equations. M of t goes over here. Greater than cost of W of t, the equation will go here. to solve that, get an inequality similar to that. It might go the other way. It might be before, it might be after. I don't know yet, but I'm going to solve it. For now, it's just solving an inequality. Not nice numbers, decimals, but use your calculator. But the steps will be the same. I'm going to, I don't know what I'm going to do. Subtract 911. You might do it differently. Keep in mind you have to worry about preserving or switching. I move my constants together on the right. I get my variable t's over on the left, that means. The way I'm doing it will not result in dividing by a negative, so I'll preserve the whole way. But if you do it differently, you may have to switch. What just happened? 0.954. Watch your decimal. Don't be like me. $36.7? Yeah, okay. We're not done. We need to interpret this in the context. I erased it, but T represented the years since 1980. When we're talking about years, we want whole numbers, so we're going to round that to a whole number. Just round the usual way. So we're going to reinterpret that as T is greater than 37, and then I need to interpret that as before or after the year blank. Which you don't have to write that full sentence, you can just condense it down to just that, but I want to get a template going. Making sure we know we have to make two decisions here. I can draw a little number line. I normally wouldn't do this. This is me just making sure we understand. So 37, which way am I shading for this? It's T is greater, this way. And those are the years after. This is, what year is this? 2017. Yeah? Okay, my reference year was, I'm all over the place. I would add 1980 to it, and that's going to give me 2027. That's the year in question. But they wanted to know what years, and that's multiple years. It's all these years, all the T's that make this true, which are 2027, 2028, 2029, 2030. It's all the years before. Sorry, it's all the years after. I meant to say that. It's the years after 2027. And obviously don't give an answer in this messy. Clean it up, but I'm not picky about it. Anyway, make sure you understand that. Inequalities, years, you're going to be telling me it's after a certain year or before a certain year in different situations. Okay, I'm going to pause here and we got one more thing to do. So, yeah. Okay, this is a new sort of problem. It's still using systems to model data. Here we're going to talk about a wedding planner. Has 150 guests to feed. Oops. And plans to offer a chicken dish and a vegetarian dish. Or chicken entree and a vegetarian entree. I'm going to use dish. I know how to spell vegetarian dish. The chicken plate costs $120 per plate, and that is reasonable. People gasp when I say it, but no, weddings are expensive. That's $120 for a single plate for a single one of the guests. And the vegetarian plate or dish, what do I say? Vegetarian plate, oh, plate's fine. I meant dish here, but I don't really. Costs $90 a plate. And when you add up all those costs, it's going to be quite expensive just to feed your 150 guests. It's a pretty big wedding. It's pretty much average cost of wedding catering, from my understanding at least. And the total cost will depend on how many people choose a chicken or how many people choose a vegetarian. Hopefully more people choose a vegetarian, so it's going to cost us not as much money because it's a cheaper dinner. But if we know the total cost was $16,440 just to feed your guests, from that figure you can then figure out how many people chose a vegetarian and how many people chose a chicken. Such a question. If the total was $16,440, how many of each dish was ordered? This is a very common type of problem. It's solving a system of equations. This one will be linear equations, so it's what we did in homework 25. Okay, where I gave you, don't write this down, where I gave you 5x minus y is equal to 23 and x plus y is equal to 6. And then you solved it for x and y. You actually made it into an ordered pair. Anyway, that technique of solving a system to get your chicken people and your vegetarian people is going to be what we're applying here. This is not the equation though, I just completely made that up just now. But it's going to illustrate the main thing. We are expected to come up with our own system of equations based on that information. So we're going to get two equations, and then we're going to solve them. For the chicken and the vegetarian, we don't have to put in an ordered pair. There'll be two blanks for, well, yeah, there'll be two blanks for chicken, blank, and vegetarian. And you can't really have a person ordering a fraction of a vegetarian plate. So these should be whole numbers, no negatives. Positive numbers of people will order chicken, positive whole number of people will order vegetarian. These are designed to work out with an exact whole number amount. So if you get decimals, something got messed up for sure. Okay, but we're going to have to set up our own. And that's going to be the tricky thing. And one way to kind of make it a little bit smoother and not too confusing is to not go with x and y, because then you lose track of which one is which. I'm going to use variables that are clearly indicative of the two different entree options that the guests have. Chicken, I'm going to use C. And vegetarian, I'm going to use V. Because why not? It'll literally be easier for us to keep track when we build our equations. Because again, we have to build a system of two equations. Sometimes they refer to it as, if you have two unknowns, you need at least two equations to solve for it. And they'll refer to that system as two equations in two unknowns. Okay, so let's talk about it. The money is a whole thing. $120 per plate for the chicken, $90 per plate for the vegetarian, total cost of $16,440. We're going to need to do all that money stuff, but that's the more complicated equation. The first equation, the easier one, it doesn't have to be first, but I'm going to do it first because it's easy, is figuring out what to do at 150. C is the number of people that order chicken. V is the number of people that order vegetarian. We're assuming, I didn't write it, but we assume one plate per person. So basically, we need a total of 150 plates. And we got C chicken plates and V vegetarian plates. So think about how the C, V, and 150 are all related. And it's a pretty simple equation. The money one's harder. You need those total to add up to your total number of plates, which is the total number of your guests. The chicken plates plus the vegetarian plates, there needs to be 150 total plates served at this wedding. Okay, next is the money. Now, for all, you have C chicken people, and they're gonna pay $120 each. And just like with the cab and the miles, that means the total cost of all the chicken plates is, you're gonna do $120 per chicken plate times that, and that'll tell you the cost of all the chicken plates that you have. That's not the total cost of the wedding, that's just the chicken plates, but all of them together. $120 per chicken plate times C, an unknown number of chicken plates. I want to ultimately use the total cost, so what I'm going to add it to? The total cost of all the vegetarian plates. Each one costs $90. I'm going to multiply that by the number of vegetarian plates that I need. $90 times how many? I don't know, but we're calling that unknown V. So that's the cost of all the vegetarian plates. Add them together, and what do we get? Well, according to us, they're billing us for $16,440, so that's what it should total to. Okay, so a lot of times you have the two variables, and they're going to be like adults and children going on a field trip, or I forget what else I have, but and try to use variables that are indicative of the actual thing they're representing. A lot of times the first equation is going to just be the total of them, and then the other one's going to be money or something else, or I don't know what else, but yeah, so that's a more complicated one, and that's our system. Okay, from there we're solving via substitution, so I'm going to fly through that pretty quickly. I'll refresh your memory. You pick one equation and one variable to solve for, and try to avoid fractions. One of those is good. They both have coefficient of 1. So either that C or that V, either one will work. I'm going to solve for that C. And I'm not going to show all my steps. I'm going to kind of skim along. I subtract V from both sides, I get that. Solve for C. I substitute that into the second equation, the other equation. So this equation here, I'm going to copy it down. You will need a calculator for this for sure. You don't want to do this by hand. I'm substituting, all I did was copy it down, because I like to do that. And then right below it, so I can see every piece and not miss anything, then I'm going to substitute in place of C, I'm going to substitute in 150V, sorry, 150 minus V. And I'm solving that. That's an equation in just V. It's ugly, it's got big numbers, but it's solvable. I know how to do this. And again, we should get whole numbers when we do this. Watch your minus signs, that's the most common mistake. I got to distribute this, make sure you're conscious of how many zeros there are. Okay, so distributing the 120 times 150, 120 times the negative V. I'm going to clean up this side first. This side I can combine like terms. It's going to be negative 30V when I combine those V's. The 18,000 is separate. So just simplifying the left-hand side from there. I'm now going to move all my constants opposite the variables. So my variables are here, negative 30V. My constants have to be on the opposite side. So I will subtract 18,000 from both sides. Oh, that ain't right. Oh my god. I'm having issues. Negative 1560. Okay, don't worry about the negatives. They're going to cancel out. Because I'm going to be divided by negative 30. This is equal, so I don't have to worry about switching or preserving. But the negatives do cancel. Again, you can't get negative numbers of vegetarians, but we won't, because the negatives are going to cancel. 52. Nice round number. Sounds reasonable. Okay, make sure you don't just circle that and go home, because that's just the number of vegetarians. I need the number of chicken plates. The last step is to take that V is equal to 52 and substitute that value into either of the original equations, or technically any equation on the board. So I can substitute it into this one, and I get the correct answer, but who wants to do that? The first one is much easier to work with. And also this form of it. This is just the same equation in a different form, so you can just go straight to that one. I'm going to do that. I'm going to do it right here in the corner. C is equal to 150 minus 52, which makes sense, because if you have 52 vegetarians, the number of chicken people are just the rest of them. 150 minus the vegetarians leaves you with 98 chicken people. 98. C is equal to 98. And if you use X and Y at the end, ooh, a lot of times people put it in the wrong place. Having 98 vegetarians and 52 chicken people is the wrong answer, and it's very different. It doesn't add up to the correct cost. So that's why it's good to use C and V in such a situation like this, or some builders that are easy to know where they go. If you do use X and Y, make sure you go back and write somewhere which one was which, because you cannot switch these. They're not interchangeable. But that's my answer. Okay, that's it for that lesson. You can do a lot of those. Not a lot, actually. I think just 2, but definitely one on the exam. So make sure you understand the setup. It is the trickiest part of this. You also do have to know how to solve your system of equations from lesson 25. Okay, that's all I got.